Hello and welcome to another free code session. My name is Jason Bach and I'm going to tackle this one. So I put in an issue to handle the thing with the test code generation so that at least it doesn't error out, and then I can actually tackle some of the things that are coming up still in Entity Framework, because there's like 300 errors that come up with that one. So I'll handle that later. We're going to look at this one. Now I've put the test in the branch and everything, and it does fail as expected. The thing after I played with the interface hierarchy and whatnot is what's happening is when you say a new here, what it should do and what it is doing is creating the definition and the implementation correctly, but it forgets about what's before. And it should still include this as an explicit implementation. So if I can detect that, we're golden, or as the kids say, we're Gucci. Now, here's the problem. And I think this relates back to some of the things I've been saying in previous videos, is if I say get mockable properties, I'm just going to do interfaces for now. I'm not even going to bother with classes because it might come up with classes, but I'm starting to really say, okay, I've got to completely redo this. But I don't want to do that right now. Is there a way to say, I think there's a is new. There is not. Well, that's just a symbol. We need to say if it's a property symbol is new. Extern? Okay. Well, that's actually kind of surprising. I thought I handled that somewhere. Let's look for new matching case in the current project. New mock instance, new line, new line. New line. Yeah, there's no... How do you know if it's a new? I mean, I think they call that in VB shadowing, but VB, what's a VB? Well, that's interesting. If we look at the syntax visualizer, it'll just tell us what the thing is here. Say it's a new keyword, property declaration. If we say use symbol, it's a property symbol. Is there anything on this that says, that gives a hint that it should be, as an original definition? It doesn't really help. Type, see, I thought there'd be like a is new, but there doesn't seem to be. There's a definition, is it abstract? Well, of course it's abstract, that doesn't help. Explicit implementations, no, we don't care about that. Is write only, language, metadata token. Locations, get method is read only required. You'd think it wouldn't just be on the parameter. It would be on a more generic thing. Underlying symbol, type custom modifiers, type is a bool, sub method. Well, this is, I know I've done this somewhere before. This has come up before. And saying new, yeah, new is going to be just anything that's a constructor, and that's not helpful at all. So, hold on. Give me 1 second here. Okay, well, ironically, I looked through the changelog and I remember putting shadow in there, but I don't remember which issue this was, and this was almost a year. This is actually a year ago, over a year ago that I did this. So I'm not exactly sure what I did, but there is up here in the methods a comment about hiding. And in fact, if I say, but the thing is, when you say hiding, there is, I think that's the thing I found out, is that there is no way to find out, are you actually hiding? Like that's what this is, but there is no is hiding, which would be nice, but that doesn't seem to exist. So what I think I'm going to have to do here is I'm going to get mockable properties as if on the interface is, I believe, it's funny that I say, is it virtual? Why would I care if it's virtual? It's on an interface. Of course it would be virtual. Whatever. Yeah, that's right, because if it's a default interface implementation, and then we have to check to see if we need 2 member identifiers. Okay. This is where we go through all the interfaces, and where it's either an indexer or it can be referenced by name. because there could be a property I guess couldn't be. I don't know. Or if it's an indexer or if it's not an indexer. So if we can't see it, we say inaccessible. Otherwise, if we currently don't have any properties, or it is an indexer, the thing we're looking at is an indexer, and we look at the methods to match. What happens if we do find something that matches? Like, we're saying if we don't find a match, whether it's an indexer or it's not an indexer. And this is actually a case where it's not an indexer. And I think all we have to do is find out, because the one that's new is going to just be handled as it is. We don't care about changing that. I think we're fine here with this if, with this for each. And then we need to go through all the base interfaces. And we get to this point in here. This is where the magic's got to happen. So we're saying if we don't find any properties where it doesn't match an index or it doesn't match a property, then we're saying we're going to have to, we then determine, right, because we're trying to figure out which base interface property group it goes to, because all these base interface properties, I think what's happening here is we're not including it because of this. So we never get into here. I think that's what's happening. Let's debug that and see if that's true. So we know it needs to get done. And then we know we need to do that. So then let's run this and see what happens. Okay, so if my logic holds, we have one property, and this one should be the value of exclude, and it should have a setter, but not a getter. So the get method is null. The set method is probably not null. Okay, cool. So we do have that. And now we've gone through and we're now looking at all the properties. This one is an exclude that should have a get, but not a set. And that is also true. Okay. So this is the problem. We don't get into this, I bet. Yep, we don't. Which makes sense. What we need to do, though, is find it when it would actually be in the base interface property groups. I'm not really sure how that works. Lists of property symbols, because I think we group them by, are you in the same? Would be interesting to say the symbol equality compare should pick up if one of these are actually in there. Like, you shouldn't even have to go through all this crap. You know what I mean? But this isn't true, because this property would actually give you a setter, not a getter. I don't know if we would consider that to be the same, but we need to capture it. We still need to capture it. Okay. So we need to be able to get into this. So in the case where it is a property and the name is the same and the type is the same. So that's actually interesting. Shouldn't have we run into a case where that's actually true? We know it's not an indexer. Right? Yeah, it's not an indexer. So it would fall into this. And the value of the one that's actually in there would also say it's not an indexer. Right? Right. Okay. And the name should be the same. Like, the property name is exclude. So just to be clear, if we say properties, actually, let's clear this up and say properties of 0, value, name is also exclude. But the types are going to be different. Why would I do this? Why would I care about the types? They're not going to be the same. The self-based property, we're trying to find that they're both properties have the same name. Oh, and they're types, they're bools. Yeah, okay, I'm sorry. I was thinking the wrong thing. That should be a bool, and self-based property type should be a bool, right? Yeah. And so if we did this, except change it just a tiny bit, so we say this is actually properties of 0. Yeah, they're true. So I am the confused. And again, this is, I've said it many times, Boolean logic can be the thing that bites me. So we know it's not an indexer, and this is not an indexer, and their names are equal, and that. Don't find any, then we just include it. We don't care about it. Okay, I think I'm onto something here. So if I come back here, crap, I took that off. But through the magic of undo, we can put it back there. What happens if I say this? Okay. Now I say implement. It just does that. If you want to put new there, weird, but that's okay. The only time that this gets squirrely is because we said set here. Okay. And so now if I come back up to this and I say implement, aha, the one that's there, I've already included this one. Okay. I've already included this one, but I'm not picking up this one because I need to say, does it have, yeah, and it's barking here because it's saying, God, get away, because it's write only. It doesn't like that as a design choice, but that's fine, whatever. So what I need to say here is not just are the property accessors different, because what happens if I said here get and set? Okay, so now look at what happens if we take this off and I say implement. It is now going to say, yeah, throw a new exception, whatever. It's going to include these, but now the one up above is going to include. So all we have to do is say, are there accessors different? Are there any? Because what were we doing? We say either the indexer part or, I'm sorry. I'm up here. If not, this is just the base interfaces one. Okay. If not any of these, then we need to come in here. So I think if I'm holding my logic correctly, we were saying if you don't find any where their properties or names are the same, the types are the same. Sorry. I don't know why this has always been such a struggle for me to get the logic correct, because I want to get into the if, but only for the case where I'm saying if the current properties don't have this, could I, and I'm really concerned about inadvertently throwing in a whole bunch of other things that suddenly come into play that I don't want to have anything to do with. So, and also the problem here, no, we don't need to change that. We just need to, okay, we don't need to change if it's required explicit implementation on the subtype, only on the base type, which is the one we're trying to find here. And hopefully by getting it included in here, we will pick up that it's different types. We're going to have to handle this correctly because the accessors matter. Okay. So we are trying to get it into this group. So if it is a property and the names match and the types match, then we do have one of those. And their accessibilities match. There. I think that's what we wanted to do. And of course you don't like that. Oh, did I just forget that? And now I don't feel like I did something right here. Or are you just not colorizing it correctly? Okay. Because I think that one goes with that one goes with that one, and then that one goes, yeah. I don't think it's colorizing it correctly. Okay, and I think here it's also saying you don't need unnecessary parentheses. But I like it because it shows the correct thing. Okay. If we found something that had different accessors, which I'm wondering if that's kind of what this does too, but whatever. We need to say, are they the exact same type? We could look at, and you can't look at the name. That's right. You can't look at the name because the name is this. It has no name. So you have to do that. Okay. So in this case, we have found it. So now we're just going to look through the base interface property groups and saying, are you there? If it has it, this feels like it's doing the exact same query, except it's now saying, does it have it? So I'm wondering if we should just do this. So does this, or I'm really not sure that's correct. But whatever. This feels like such an edge case. So now we need to say this. So we want it to basically get into here. And then we're going to come back down here. Now we need to say, if there are any properties of the same name but different types, then we must require explicit implementation. So this is saying, do they have the same names? Yes. And either their types are different or their accessibilities are different. So we want to say here that, or the base implementation property group get accessors does not equal value dot type dot get accessors. No, not get. Oh, just get accessors there. Okay, there. So then we would want to do this. Let's just see what happens when if I run this now. What does this do? Do we want to just, okay, yeah, let's run this and just see what it gives as differences, if it actually works at all. Okay, it looks like it did the right thing in that it put in the get thing there. Let me just try one thing though. Let me just run all the tests here and see, because one should fail. We don't want to see, because this is the one that will fail because I haven't changed it yet. But all the ones that we have, hopefully none of them fail. Like we haven't introduced another bug somewhere. That's the thing I'm concerned about by doing it this way. I know I'm kind of doing this backwards. I should just say, okay, this is good, put it in, and then leave it at that. But, okay, one failed, which is this one. So that's good. So what I'm going to do now is let's just make that. Okay, and so then what I'm going to do is restart integration tests, code generation tests, and the code generation tests with with putting in mass transit, because that's the only thing that's failing. So let me do all that work and we'll see if we've actually solved this problem. Okay, I put in the changelog that's fixed because it's fixed. No issues. I put in the mass transit now, so now we have a bunch more cases. This is no longer errors, not 10, and not 3 in binary, or not -0. Zero errors and 0 warnings. Perfect. All right, so I'll commit this, merge it, and get it closed out, and then in the next episode, we'll pick something else. Thank you all for watching. Leave comments and questions below. See you in the next episode.